So let's set this test up for a production test. What do we need to do to prove that? So we can see our master test part got us a decay of about 0.03. And so let's just go in and we'll start by adjusting the test time. So I'm just going to add 2 seconds and we'll run this test. So the same test we're doing is it's going to fill. Now we're actually filling for 2 more seconds to let the thermodynamics calm down. We see not as much decay during the settle step. And at the end of the test, we see this asymptotic curve where it's dropping, but now it's starting to flatten off and level out to show it's less decay. So now we can see by adding 2 seconds to the test, instead of getting a 0.033, now we get a 0.020. So the part didn't get sealed any better. We're just seeing the thermodynamic reaction take place and we're seeing how we can nullify it. Well, let's go back in and add 2 more seconds and see what we can do to that. So again, the test goes on as normally, but now we're letting the part sit and just sit at that pressure. If the part were to expand, we would top it off, but because we're letting it just sit, the thermodynamics are severely dropping off. And so now we see, now we get a decay even smaller. So by adding more time, we get less and less natural decay from the part. So we get a 0.012. So you can see by adding more and more time, we're getting better results. Well, let's see what happens when we add the leak standard to it. Remember, we didn't even, we had barely 0.01 difference between the two. So with adding more fill time, and we let the thermodynamics calm down, now when we get into the test step, we see a greater decay. So now at this point, we're seeing 0.02. So we have just about 0.01. So the separation didn't get very much. So what we can do is come back in and change the test time so I can add some more time to it. And now we're going to do this process of going back and forth. What we want to do is run the master part and then run the master part with the leak standard and see where the separation gets us. Now, running with a sampling of 1, we run into some dangers. So the more we test a part, if the part had some compliance or some stretch, the more that compliance is going to stay. It's the same idea as the party balloon, right? The first time you blow up that balloon, you about blow your eardrums out because it's very hard to get that balloon to go. Well, if I let the air out of it and blow it up a second time, it's much easier because the compliance is already there. So it wants to get to its shape, its final shape, faster. The same can happen in leak testing. If we're using 1 sample part or a few sample parts, because that's all we have, what we'll tend to see is the results will just get better and better naturally on their own because of things like compliance. So one of the things that we recommend is when we do this process of changing the times, what we want to do is we want to let the part rest. When we go into a production test, we're only going to get 1 chance at this. So we need to better simulate that while we're doing the setup now. So the way to do that is to let the part sit and go back to its virginal state, so to speak. We recommend that there should be at least about 2 minutes in between the testing. So as I'm doing testing with a very small sampling, I'm going to sit and wait. In this case, as we show it now, we're not going to do the waiting time in between, just so that you get the idea of how manipulating times gets us better results on the screen. But we want to wait. If I had maybe 10 parts to be able to do the setup, what I would want to do is this same time cycle, but I would want to do all of them in a master part without the leak standard. I would go 1 through 10, because by the time I got back the way all through of them, and I got back to 1, it's had sufficient time to return back to ambient temperature. It's had time for the part to possibly reduce back in size because it was expanded due to the pressure. And then I can go plug the leak standard in and then go through 1 through 10 again with the leak standard plugged in and get the results. That way I'm taking a better sampling and I'm getting a more realistic test because I'm not just doing a sampling of 1 like we're doing here. But really what we want to show is that the iteration of adding time, whether it's in the fill step or the test step, helps us to get the separation that we need to see.